Today in geometry, we are looking at chapter 9, section 1, so 9.1, which is all about translating figures and using vectors. So we're going to start out with some vocabulary. So first, a transformation. So this is a transformation. Is an operation that moves or changes a geometric figure in some way to produce a new figure. That new figure is called the image. The original figure before any transformations is called a pre-image. The notation for a pre-image and an image, we have ABC. That will go to A prime, B prime, C prime. So they have an apostrophe, which is read as prime in math. So ABC goes to A prime, B prime, C prime. The three main types of transformations that we will talk about are translations, which moves every point of a figure the same distance and the same direction. Then we have a reflection, which requires a flip and uses a line of reflection to create a mirror image, and a rotation, which turns the figure about a fixed point. Translations, reflections, and rotations are three types of rigid motions. A rigid motion, or also known as an isometry, is a transformation that preserves length and angle measure. So the very first thing we're going to do is practice to determining if the transformation is a rigid motion. So if length has changed or angle measure has changed, then it is not a rigid motion. Okay? So number one, we have our pre-image, what we started out with, and then the new image. We can definitely tell that the new image is much smaller than the pre-image, so this is not a rigid motion because the length changed. It's obviously not the same size. Number two, my pre-image and my image, they look to be the exact same length. None of the lengths have changed, and none of the angle measures have changed. So yes, this is a rigid motion because the length and the angle measure are unchanged. Neither of them changed any. And then finally, number three, we have our pre-image and our image. We can tell the image is much larger than the pre-image, so this is not a rigid motion because the length changed again. So again, that's how you tell if something is a rigid motion. So now we're going to practice translating a figure in the coordinate plane. So first we're going to graph the quadrilateral ABCD with these vertices. So A is at -1, 2. So there's my A. B is at -1, 5. There's B. C is at 4, 6. And D is at 4, 2. And so here is our quadrilateral. It says find the image of each vertex after the translation of xy to x plus 3, y minus 1. So in order to find A prime, I need to add 3 to my x and subtract 1 to my y. So my A, the x, started out at -1, so I'm going to do -1 plus 3, and that's going to put me at 2. Then I'm going to take the y, my y started out at 2, and I'm going to subtract 1, and that puts me at 1. So A prime will be the point 2, 1. B prime, my B started out at -1, but then the rule says add 3, so that puts me at 2 again. The BY started at 5, then the rule says subtract 1, so that puts me at 4. So B prime is going to be the point 2, 4. C prime, my x started at 4, I have to add 3, so now I'm at 7. My y started at 6, I have to subtract 1, so now I'm at 5. So C prime is the point 75. And then D prime, I started at 4, again, the rule says add 3, so I'm at 7. The y started at 2, so when I subtract 1, I'm at 1. So D prime would be the point 71. So I'll switch colors and graph that one. So 2, 1, there's my A prime. B prime is 2, 4. there's P prime. 7, 5 is C prime, and D prime is 7, 1. So there is our new quadrilateral after the transformation of x plus 3 and y minus 1. So now we're going to kind of go backwards a little bit. Now they're going to tell me that, I'm sorry, we're not going to go backwards yet. It tells me that the image of xy is x plus 4 and y minus 7 is p prime q prime. The endpoints p prime are at negative 3, 4, and q prime are at 2, 1. Find the coordinates of the endpoints of the pre-image. So here we want to find out what did p and q start out as. So again, I know that p was going to be x plus 4. The rule x plus 4 got me to p prime, which was negative 3. So I just want to solve that for x. So when I subtract 4 from both sides, I get x is negative 7. The y value of p, the rule was y minus 7 to get to the y value of p prime, which is 4. So now add 7 over, and I get y equals 11. I'm going to do the same thing with my q. So the rule for q, again, x plus 4 equals, gets me to the q prime x of 2. Subtract 4 over, and I get x was at negative 2. The y minus 7 equals the y value of q prime is 1. So when I add 7, I get y equals 8. So my original point P was at negative 7, 11, and Q was at negative 2, 8. And then after the translations, the transformation of x plus 4 and y minus 7, they ended up at negative 3, 4, and 2, 1. And so we started with the image, and we found what the pre-image was. So now they're going to give us a picture of two triangles already graphed, and they want us to write the rule for the translation of triangle ABC to triangle A prime, B prime, C prime. I only need to pick one of these points because they all had to move and have the exact same translation. So it doesn't matter which point I pick. I'm just going to pick point B. So I see that point B is at 1, 1. So B prime is at the point 1, 2, 3, 4, 5, 6, 7, 8, is at the point 9, 5. So I need to find out what did happen. What did I have to do to the 1 to get the 9? So 1 plus what gave me a 9? So that's an 8. So I want to do the same thing with my y. 1 plus what put me at a 5? So that's a 4, right? So I had to go right 8 and up 4. So my rule is x plus 8, comma, y plus 4. So there's our rule for the translation of triangle ABC to triangle A prime, B prime, C prime. Here, let's go ahead and look at the back. Another way to describe a translation is to use what's called a vector. A vector is a quantity that has both direction and magnitude, or size. A vector is represented in the coordinate plane by an arrow drawn from one point to another. So this picture, I have B and C labeled, and you can see I have an arrow from B down to C. This vector would be named, it has the same notation as a ray, okay? So it would be named like that, vector BC, with a ray symbol above it. The initial point is the starting point, the one that does not have the arrow. So in here, my initial point is B. The terminal point is the one that has the arrow. So that here is C. A vector will have both a horizontal and a vertical component. So this is my vertical component. This is my horizontal component. I want to see that this is my initial point. So I see that it went down 2 space. My vertical component is down 2. My horizontal component, I'm going right. I'm counting spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right 9. So my horizontal component is right 9. Now the composition, I would say vector BC. I denote that it's a vector by, instead of doing parentheses, I do these little diamond brackets. It went right 9, so that's a positive 9. It went down 2, so that's minus 2. So there's the composition of the vector, which tells me what the vertical and the horizontal components are. So now we're going to practice naming the vector and writing its component form. So here I see that this would be a vector bk. I see that my horizontal is 1, 2, 3, 4, 5 to the left, so that would be a -5. And then up 2, so -5, comma 2. This next one, vector st, my horizontal, so if I start here, I go 1, 2, 3, 4, 5, 6, 7, 8, but I'm going to the left, so that's a -8. I did not go up or down any, so -8, 0. Now we're going to look at, given a vector, use that vector to sketch a three-dimensional figure. So here's the vector that they give to me. I have to find out what is this vector. So from this point to this point, I went over 1 and up 1, 2, 3. So this vector is 1, comma 3. So I'm going to do that to each of these points. So from this point, I'm going to go over 1, up 1, 2, 3. There's my new point. From this point, over 1, up 3. From this point, over 1, up 3. And now I'm going to connect. So this one gets connected there. Connect this, and connect this, and then I can connect those. And I've created a three-dimensional figure. We'll try that again. So on this one, my vector, so I go over 1, 2, and then up 1, 2, let's see, 1, 2, 3. So I went left 2, up 3. So if I go left 1, 2, up 3, there's that new point. I start here and I go left 2, up 3, there's my new point. Starting here, left 2, up 3, puts me right here. Left 2, up 3. And again, this gets connected here. This one connects here. Connecting them. And then I can connect to make my three-dimensional figure. The last thing we're going to look at is using a vector to translate a figure. So they give me the vertices of triangle ABC. So I want to plot those points. So first A is at 0, 3. So here's my A. B is at 2, 4. And C is at 1, 0. So here is my triangle ABC. So now they tell me to translate triangle ABC using the vector 5, -1. So basically, I'm adding 5 to all of my x's, and I'm subtracting 1 from my y's. So my A prime is going to be 0 plus 5, 5, 3 minus 1, 2. My B prime is going to be 2 plus 5, 7, 4 minus 1, 3. C prime is going to be 1 plus 5 is 6, 0 minus 1, -1. So I want to plot these points. So 5, 2 puts me A prime. 7, 3, B prime. 6, -1, C prime. So there is the new translation. All right, so that wraps up section 9.1 of our notes. You will have homework over this.